All right, guys, here we go. Last remaining questions 12 through 15 now. That's all we're doing this in this last video. Starting with question number 12. Okay, first says to use the rational zero test to state the possible rational roots. So here I'm focused on 2. The 2 is the possible, the numerator should divide 2. So it's going to be plus or minus 2 or plus or minus 1. Those are the p values, yeah. The q values are things that divide the 6 here. So q is plus or minus 6, plus or minus 3, plus or minus 1. Oh, whoops. Plus or minus 2, plus or minus 1. So now if I'm looking at p over q, well, first of all, I get the whole numbers, right? If it's just 2 over 1 or 1 over 1, I get plus or minus 1, plus or minus 2. Okay, you also get 1 over 2, so a half, or 1 over 3, or 1 over 6. Or I get 2 over 2, which is already counted for as 1. Or I get 2 over 3. So 2 over 3 is a possibility. I get 2 over 6, but 2 over 6 is just 1/3. And I already have 1/3 there. So those are the possibilities. Okay, those are all the different rational potential roots. Okay, so now that I have those, I'm going to just take a guess, pick one, and try to run my synthetic division. I don't know. I like to start with 1 and -1 because those are usually easy ones to check. So here, let's do it. Bring the 6 down, multiply 1 times 6, that's 6. Add together, it's 19. 1 times 19. 19 is 20. 20 times 1 is 20, and that's not equal to 0. So that did not work. Try again. Try -1 next. 6, 13, 1, -2. Bring the 6 down first. 6 times -1, -6. -6 plus 13 is 7. 7 times -7. -7 plus 1 is -6. -6 times 1 is +6. So +6 plus -2 is 4. So also not equal to 0. Okay. All right, I'm going to continue checking the whole numbers because those are the easiest to work with. So I'm just hopeful that I'm going to get a whole number factor. But I don't know. 6 times -2 is -12. It's going to give me 1. 1 times -2 is -2. -2 plus 1 is -1. -1 times -2 is +2. All right. -2 plus 2 is 0. So that means -2 is a factor. I'm sorry, -2 is a 0, I mean. Which means x plus 2 is a factor. Right? So, and not only is x plus 2 a factor, this guy is the resultant polynomial, which is 6x squared plus x minus 1, right? So that means I've factored so far to x plus 2, 6x squared plus x minus 1. Okay. So now, at this point, I have a quadratic, right? And so I can just plug that into the quadratic formula. And that's what I'm going to do. So x equals to -1 plus or minus the square root of 1 squared, which is 1, minus 4 times a times c all over 2a. That's -1 plus or minus square root of 1 minus 4 times 6 is 24. It's negative, so it's positive 25 over 2 times 6, which is 12. Okay, so I've got -1 plus or minus 5 over 12. If I minus it, it's going to be -1 minus 5 is -6. -6 divided by 12 is -0.5. Or if I add it, -1 plus 5 is positive 4. 4 over 12 is 1/3. Notice, guys, -0.5 and 1/3, those were listed in our potential roots, right? Potential rational roots. So that makes sense. Okay, now as far as factoring the thing, so we figured out our zeros, right? Let me do this next step. So yeah, we did the possible rational roots. We used synthetic division to find all the zeros with quadratic equation. Now we're going to factor. So factoring, we kind of started over here. Let's write the whole thing down here. X plus 2, and then instead of 6x squared plus x minus 1, it's going to be x plus a half, so that -0.5 is a root, and x minus a third. So that 1/3 is a root. Yeah. Okay, so that's the full factored form. And then sketch a quick graph. So I'm gonna make myself some space to graph it here. I'm gonna erase that work I did earlier. Erase some of this work here. To graph, all I really need are the roots. The factor form is enough for me to graph with. Okay, after this I have 2 more questions to do, guys. -2 is a root 1, -1, -2. Negative a half is also a root. And positive a third. That's 1, 2, positive a third somewhere here. Okay, looking at my original polynomial to the left, it's going to be negative. All the roots have single multiplicity, I mean. So it's going to look very similar to the previous graph I made. Something like that. As x goes to infinity, 6x cubed goes to infinity. So there it is. There's a sketch. Rough sketch. Okay, that was 12. I mean, no. Oh, yeah, that's so. Oh, what? I only did 1 so far? Shucks. I thought I did 2 in this video, but I guess the other one I did was the previous video. Well, these things are taking long. All right, well, that was 12. Let's continue on, guys. Let's just power through. 11's done, 12's done. So we got 3 more. All right. Or maybe I'll take one. Maybe I'll take a question out. This is gonna be too long. Okay, let's just do the next one. I got 3x cubed minus 2x. Okay, so p has to divide 2. So p is plus or minus 1, plus or minus 2. Q should divide 3. So q is plus or minus 1, plus or minus 3. That means p over q is 1 plus or minus 2, or plus or minus 1/3, plus or minus 2/3. Okay, as usual, I'm going to start by checking the whole numbers. So let's check 1. I've got 3, -2, 3, -2 as my coefficients. Bring the 3 down. 3 times 1 is 3. -2 plus 3 is 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4, and that's equal to 2, not equal to 0. Okay, let's try -1. 3, -2, 3, -2. 3 comes down. 3 times -1 is -3 this time. I mean, what am I talking about? No, it's not. No, yes, it is. 3 times -1, -3. -3 plus -2 is -5. -5 times -1 is +5. 5 plus 3 is 8. 8 times -1 is -8. And that's -10, so no, not equal to 0. Okay. Now let's check +2 and -2. 3, -2, 3, -2. Same deal, bring the 3 down. 3 times 2 is 6. 6 plus -2 is +4. 4 times 2 is 8. 8 plus 3 is 11. 11 times 2 is 22. And that's going to be 20, so it's not 0. Okay, last chance with the whole number. If this doesn't work, I have to go to the fractions. 3 down. 3 times -2 is -6. -6 plus -2 is -8. -8 times -2 is +16. 16 times 16 plus 3 is 19. Yeah, it's not gonna work. 19 times -2 is -38, which is -40. No, not 0. All right, then let's go to a third. Then let's change color. 1/3. 3, -2, 3, -2. Bring the 3 down. 3 times a third is 1. -2 times, -2 plus 1, is -1. That's -1/3. 3 plus -1/3 is going to be, that's 9/3. That's going to be 8/3. 8/3 times 1/3 is going to be not equal to what I want it to be. So I'm not going to even finish that because it's not going to equal to 0. So let's try -1/3. 3, -2, 3, -2. And you know, it's kind of good you guys are seeing me work through this whole thing, because this is kind of what happens, yeah? This is kind of what happens. And it ends up being kind of tedious if you don't guess the right one quickly. -3 times the third is +1. Positive 1. That's 4. That gives me -4/3. So it's not going to work. I'll just write that. It's not 0. Okay, it might be one of the last ones I guess. So 2/3 and -2/3. Some last two chances. Let me just actually make space here. Delete some of these guys. Oops. Yeah, let me get started at least. Okay, 1 to 2/3 and -2/3. Oops. Yeah, that's good. I remember what it was. So 2/3 and -2/3, last things to check. Start with 2/3. Coefficients 3, -2, 3, -2. Bring 3 down. 3 times 2/3 is going to be 2. 2 plus -0 is going to be 0. Times 3, plus 3 is 3. 3 times 2/3 is 2, and that is 0. Yes, we found it, guys. We found it. 2/3 is the 0. Great. Okay, that is great news. This also gives us, remember, the resulting quadratic. This is 3x squared plus 3. So far, I factored my original polynomial to x minus 2/3 and 3x squared plus 3. Oh, wait a second. Oh, no, yeah, never mind. Okay, but this one's easy to factor. I can factor out a 3 here, right? So I get 3 in the very front, x minus 2/3, and by pulling out the 3, I got x squared plus 1. Okay, now it's making sense that I didn't see any other roots, because look, this is x squared plus 1. That guy has no zeros, right? If I plug in negative or positive, this guy is going to always be at least at minimum 0. If I plug in a negative, it's going to be positive. And I'm adding something. So it's never going to dip below 0. It's never going to hit 0. So only got one root. Okay, so that makes my graphing also easier. All right, so now I went through all that trouble, but at least the graph shouldn't be too bad. Finally found my one root. My one root was 2/3. So here's 1. 2/3 is around there somewhere. Yeah. Okay, and now it should be passing through that thing. I'm trying to think about how curved this thing should be. It should be a curve. I have another non-root, x squared plus 1. So that's where it crosses the axis. And then what am I looking for, guys? I'm looking for, oh yeah, I'm sorry, the end behavior. Okay, end behavior. So if I plug in, looking at my coefficient here, if I plug in negative, something very large negative, it's going to be negative. So it's going to approach from the bottom, somewhere like this. And I have a cube term, so something like this. And then in the end, it should end up positive because if I plug in a large value here, that's going to be a large number there. So something like this. Okay, I'm not so confident about the shape of that graph. I know it passes through the point. To the left, it's down. To the right, it's up. But let me look at a graph for that one. So, what was that? 3x cubed minus 2x squared. 3x cubed. Minus what? 2x squared. Plus 3x minus 2. Okay. Yeah, so I got the general shape right. It's kind of similar to the normal cube function, yeah. Wait a second. Oh, forgot the x here. Okay, yeah. Whew, scared me for a second. Okay, oh, yeah. See, this is at 2/3, 0. That's the one intercept. Here, this is 0, -2. That's the other spot. And then see the curve kind of has that same sort of shape as an x cubed. So, yeah. I mean, mine's kind of crude, but sort of. I guess it's more like this. But yeah, okay. All right, guys. Those two took a long time. So I think this video is getting too long. So I'm gonna have to cut it off here. And it's looking like I'll need a fifth video this week.